NASA has funded a groundbreaking rocket propulsion system that could be able to revolutionize future deep space missions, including those to Mars. Even the shorter Mars missions have round-trip flights of around 15 months, but the pulsed plasma rocket, or PPR, being developed by Howe Industries could shorten it down to just a few months. The way the PPR works is that a likely gas fuel will be ionized to create plasma. By rapidly discharging electrical energy into the plasma, it can generate short, intense bursts of plasma rather than running continuously. Next, an electromagnetic field can be used to accelerate the plasma through the magnetic nozzle, thus creating thrust. The amount of thrust this generates could create potential speeds of up to 500,000 miles per hour. The rocket will also have a high specific impulse, which is a measure of how efficient an energy creates thrust. To use an example, the SpaceX Starship has a specific impulse of 380 in the vacuum of space, where the PPR has a specific impulse of 5,000. This means the PPR will need a much lower fuel payload to operate. The creation of the system stemmed from research done on the pulse fission fusion concept. However, the PPR is smaller, simpler, and more affordable than the previous concepts. Not only could this tech allow further mission range, the PPR could also support much heavier spacecraft, meaning they could install additional shielding to reduce the crew's exposure to harmful high energy particles, otherwise known as Galactic Cosmic Rays. Phase 1 of the NIAC study focused on the neutronics of the propulsion system, designing the spacecraft, power systems and necessary subsystems, and analysing the magnetic nozzle capabilities. Having now completed this phase, they move on to phase 2, which involves optimization of the engine, proof of concept experiments, and designing a spacecraft concept to better protect crewed missions to Mars. If you enjoyed this video, make sure to like and subscribe, and also check out this playlist on future space tech.